So dear world, welcome back in today's video to understand the pre-order traversal using iterative. So previously we have observed that using recursive we have applied the pre-order traversal. Today we'll be observing the iterative method. So you might be thinking that what is this iterative? In childhood we have observed the for loop again and again. So that is iteration method. So let's start understanding. So what is pre-order traversal? First we should know that. So the in-order traversal formula is like this. First we visit the left child, left, then we visit the root, and then we visit the right, and this is applicable for inverter. This is for inverter. And now today we'll be implementing the pre-order. So if this root, if it comes in the pre-position, it becomes the pre-order. So the pre-order traversal will be like this. First we'll be visiting the root, and then we'll be visiting the left portion, and then we'll be visiting the right portion. So that is the main funda that we'll be visiting. Using recursion it is very easy, and I've already made you understand. So today we will be visiting using the iterative process. So whenever we start with iterative process, we will be starting with the root node. We'll be starting with the root node. So we'll be starting from the this node. So first we have to, once we start from this node, our core focus will be to print this root node. So once we encounter this one here, we'll be just printing the one. So first time we printed one. Now we have to print all the elements in the tree. The entire tree that we are observing here, we have to print all the elements of this tree. So once we do it, for that we have to utilize stack. We have to utilize stack because in recursion also we utilize inbuilt stack. So we'll be utilizing a stack here. So let's call this is our stack in today's video, and that is the stack. So we'll be inserting the elements in this order. First we'll be inserting, if the node we're working, first we'll have a current node, and if this node is having left and right child, so first we'll be inserting the right child. First we'll be inserting the right child, and then after inserting the right child we will be inserting the left child. So now we are dealing with ones. So once we have processed the one, now we will be inserting its right child, and then we will be inserting its left child, pushing that 3 into the stack. So once here the stack 3 comes into this stack, this small stack, so we'll be writing this 3 like this, 3. So we have pushed this 3. So this is the actual representation of the node. So we have pushed this into 3. Now we will be pushing the left 2 like the same. So we simply write it just like 2, that we have pushed the 2 into this stack. So now 2 has also been pushed into the stack. So now 3 and 2 both has been pushed, and we have pushed both the elements. So now what we'll be doing, now we'll be processing the current node elements. That means once we have processed the root, we have processed the root elements. So now we have to process the left element. So once we come here, now our second task is we have to process this element. So now we will be, just after that we will be again popping the element back, popping the element. So this is called pop. We'll be popping the element. Once we pop the element, this element is removed, and we just substitute it. So now we have put the left element 2. So once we have put the left element 2, now we'll immediately, once we have just pop the element 2, once we have popped the element 2, immediately we'll process its right and then left. So first we'll be processing in the right. So again we'll be inserting this right into the pop. So now we'll be inserting the right like this. Right 5 will come here, and after this 5 again we will also push this element into the stack. So this will come here 4. So now after that again this is having 4 and 5. So what we do, after we get, we again just pop the element. So previously we have popped the 2, now we pop the 2 elements 4 from here. So 4 is erased from here, and we write here 4. So after that we again just pop. Yes, we again just pop the 5 element from here. So once we have popped all the elements from this section, we actually get the element 3 in the last here. The 3 is left. So if there is 3, so now we actually process this element, and once yes at the end we just pop that element from here, and we write like this. So this is the task that we have to perform, that we first have to use a stack, and then we will process the array. So let's understand with code examples that how we can org. So first we will be implementing the stack for this. So let's start by implementing the stack. So first we'll be importing the stack like this. Import java.util.stack. So now first we have imported the stack, and now we'll be utilizing the preorder traversal. So first we'll be naming the function as void preorder traversal. Void preorder traversal. Okay. So now we are starting. So the base condition first will be checking that all the nodes we stop when we encounter the null. Previously in in order traversal, I made you understand that whenever we encounter null, we just stop. So first we'll be writing that line that if root equals to null, if root equals to null, then we will stop the program. That means we will be utilizing return. So okay, this condition has been done. Now we will start the next condition. We have created a stack here, stack. So now we have to create the stack. So okay, let's create the stack like this. Stack, and stack actually stores the binary tree node. So we'll be storing binary tree node. Stack binary tree node. So you might be thinking, what is this binary tree node? So all those nodes that you are observing like this, these are all a binary tree node. 4, this is 3. So these all are binary tree node. So stack binary tree node, stack that is equals to new stack. So now we already created a stack. Now we will be pushing the root because we always push the first root element first. So we'll be just pushing the root. So stack.push, stack dot push the root. So now we pushed the root. That means our stack is having some element. So we'll be start inserting that if stack is not empty, then we'll be continuing the further process. So now we'll be check that if the stack becomes empty, that means it becomes all the elements are processed, then it becomes empty. So we will not processing any further. So we'll be only working if that stack is not empty. So for that we'll be writing if not of stack dot is empty. That means if stack is not empty, then only we will be proceeding further. And for that, now we'll be creating our current node. So tree node, current node. This is binary tree node, current node. So we tell this node current node, and we will be implementing the node we want to process. So what the node we want to process? The node what will be popping from this stack. That is what will be popping from this stack. That is called stack.pop. So if we just apply the function stack.pop, stack will return us the topmost element of it. It will return us the topmost element, and we'll be processing that element, and we'll be simply printing the value of this. So system.out.println current node dot data. We can call it data or value. It depends on by what we stored. So okay, now we have stored. Now we'll be checking the right side. That means now we are processing the tree. We are processing the tree. Let's say we are processing the 2. We are processing this 2 like this one 2, and this is 4 5. Now we'll be checking, because here we will be first inserting the right side, that is the concept, and then we'll be inserting the left side. So we'll be checking if our right is having data. That is, if if current dot if current no current node dot right is having data that is not equals to null. If it's not null, that means it is having data, and we will simply push that data. So we'll be just applying stack.push current node dot right. So now we have pushed the current node. Now we have to push the left node. So for that, again we'll check if our left node is not null. If current node dot left not equals to null, if that is not null, So we'll be pushing that one, stack dot push current node dot left. So now we are just pushing the left node, and this is we're finishing writing the function. So we have checked all the condition. If that is not null, and if it encounters null, it actually stop. So this is it. First inserts from inserting from the root one by one, 2, 4, 5. Then it pops the element and it processes the element. That means it prints the element. So this way we actually get the elements, and if we just run this pattern, we will get this order. So let's write all the program lines in the VS Code, and let's see if it actually works or not. So okay, welcome back to the VS Code. So we have previously wrote all the code lines for our previous code. This is binary tree node. So this was the node that we have to create while time we are working, that I didn't make you understand because it's very easy, and I've already previously told in other videos. So we have to create this binary tree node data. It's important because that is the node what we thought we are working. Every tree node 2 is a binary tree node, and now this is the class. So first we'll be creating this root we have created, then this is traversal by level in order traversal, and now we'll be implementing the pre-order traversal. So void pre-order traversal. Okay, and this is main function where we have created the tree. So now we'll be checking like this same, we'll be checking the base condition, that if root that is equals to null. So if root equals to null, will be simply return. Now once we have checked this condition, now we'll be creating the stack and we'll be pushing the root. So stack of binary tree node, stack equals to new binary tree node. Okay, now we have created the stack, and now we'll be simply pushing the root, stack dot push of root. So we have just pushed the root. Now we'll be checking the condition that if stack is not empty, while stack dot is empty. So stack dot is empty will return us if it is empty, and we will only running the program if stack is not empty. That means stack is having some element. Then simply will be first pop an element tree binary tree node that is equals to current node that is equals to stack dot pop. So we just popped the element from here, and once we popped the element, now we'll be just printing this element system.out.println current node dot data, and now we have printed the element. Now we'll be checking if its the write is having any value. That means if current node dot write not equals to null, that means if it's having data. So current stack dot push will be just pushing that stack dot push current node write. Now again current node dot left not equals to null. If left is also null, we'll be simply pushing stack dot push current node dot left. Okay, so I made you understand the pre-order traversal. So we have implemented the pre-order traversal. Now let's see if it works or not by printing. So for that, we'll be simply compiling the Java compile file. So okay, now we'll be just compiling the Java compile. So Java compile, it tells cannot infer binary tree node. Okay, we are actually creating a stack, not the object of binary tree node. So it will be stack. Again Java compile, Java binary tree. And as you can see, we got 42513. So now let's match with our that we got 42513. So here we have printed 42513. First root is printed, but we got 42513. Okay, we are just thinking that we got some wrong answer. That is not actually what happened. That now notice that we got the 42513 of printing by in order iterative traversal. So this is the order of in order, and we are right now working with pre-order. So we have to just call this function. We didn't call. That's why I also got confused that how I can get it. So okay, now we'll be calling the pre-order traversal. So system.out.println system.out.println printing by pre-order traversal. Pre-order. Okay, now tree dot pre-order traversal. So okay, now we'll be printing the pre-order traversal. Oh, sorry, I just added those two lines of code, and now we'll be printing the Java compile. Just I will be compiling Java compile and then Java, and now you can see printing by pre-order traversal, and we got 1 2 4 5 3. So now we will again match with our concept if that's correct or not. Now we can see 1 2 4 5 3. So it actually correctly matched with our console. So we've all understood the concept of pre-order traversal. So in next session we'll be meeting on the post-order